And welcome to Climate Chat. I'm your host, Dan Miller. And today we have a guest, Texas A&M climate scientist, Andrew Dessler. And Andrew has done a lot of work in the last few months, working on a scientific response to the Department of Energy's Climate Working Group report on climate. Actually, I don't remember the exact title there, but basically, it was the Secretary of Energy brought together who I would describe as climate deniers to write a report on climate change. And surprise, surprise, they're they say climate change not so bad, not so dangerous, and et cetera, things like that, in very high level. And it wasn't really grounded in science. So Andrew and a bunch of his colleagues went out to try to provide a response to this report. So that's what we're going to talk about mostly today, but hopefully get into other subjects as well. So first of all, Andrew, welcome. And to start off, why don't you just give us a little bit of your background in climate science, the kind of research areas you focus on and that kind of thing?
Sure. I have spent most of my career looking at global climate physics, things like water vapor feedback, how the atmosphere moistens as it warms up, cloud feedback, how clouds change as the climate warms. And then a few years ago, I basically decided that we understand the physics of the climate system. It's really not that complicated. And certainly there's uncertainties that still need to be addressed. But we understand enough to know that we need to deal with this problem. And so I've been spending the last few years, I've really been focusing on impacts of climate change, sort of the human physical interface. You have these changes in the physical climate system, which we pretty much understand, but how the human system is going to respond, we really have no idea about that. I'll just give you one example. 5 years ago, nobody was talking about insurance, homeowners insurance. And now we see homeowners insurance, this real keystone of our economic system, buckling under the pressure of climate change. And so these are the kinds of things that I'm very interested in now.
Okay. And let's jump forward to the Department of Energy report. How did you, I heard this story, so it's kind of interesting, but how did you end up being the one leading this effort to provide a response to the report?
So, I saw on social media that the DOE had released this climate report, and I think I had heard it was coming, and they released it. And so I looked at it on, I think it was July 29th. I downloaded a copy and I just started looking at it. And, I know all the authors, or 4 out of 5 of the authors. I've dealt with them in various ways in the past. I'm familiar with their work. And I looked at the report and I thought, this is terrible science. This doesn't reflect what we understand about the climate system. And in many ways, it made a mockery of science, the way they only cited 1% of the peer-reviewed literature. And that 1% they cited, they often cited incorrectly. The arguments, there was cherry picking, there was misrepresentation of the science. And I sort of thought to myself, I have to respond to this. I didn't know how I was going to respond, but I thought somebody's got to do something. So I put out a message on Blue Sky, maybe on Twitter also, just saying, if you're interested in, or I guess my first message was, there should be a coordinated response. Is anybody coordinating a response? And what I realized is that by saying that, I was implicitly volunteering myself, because I got a bunch of people saying, I don't know anyone that's volunteering, but I'll help. And I got a lot of responses of, count me in if you do something. So I kind of said, okay, well, if no one else is going to do it, then, I guess I have to do it. So I essentially set up a sign-up sheet where people could sign up for whatever sections they wanted to work on. And then people just started writing. And I
How many
didn't.
people in total did you end up getting to help you?
I think there were more than 85 people who ended up working. We had a bunch more people sign up, but some people, things came up or they just, they kind of dropped off the list and they never did anything. So 85 people eventually were authors on the report. And, I, up until the report was basically put together, I had no idea what it was going to look like, because I basically said, okay, I have a sign up sheet, write stuff, send it to me on August 18th. And, until August 18th, I didn't know if, maybe nobody would send anything in which case we wouldn't have had a response. And then I remember that night, evening of August 18th, I put the spreadsheet together where I had all the sections we needed, and I started putting in the status of them. And I realized that we had covered everything. I said, by God, we did it. And until that point, I didn't know we were going to do it, and we did it. And I think it was a very successful effort to critique the report in a very effective way.
So you mentioned that the authors of the DOE report. For the benefit of those listeners who don't know really anything about this report, where it came from, the DOE report, where it came from, can you just tell us a little bit about some of those authors and why they might not be the most appropriate people to write a report on climate change?
Well, I think most of the people listening to this, I'm guessing, have heard of the 97% statistic that John Cook came up with in his analysis. I've always thought that number was wrong. It was really 99.9% of scientists kind of agree on the major claims. The Earth is warming. Humans are primarily responsible for this warming, and sort of future warming will be geologically large. And, I would say that the DOE authors are part of that 0.1% that disputes those claims. And I'm not sure they explicitly dispute those claims, but they dispute enough claims that we basically know are that are like those claims that we can all agree on. That I wouldn't refer to them as climate deniers as much as climate misinformers.
Right. Yeah, and back, the first paragraph of your executive summary sounds fine until you get to the second paragraph. Like, it starts off with we're releasing greenhouse gases that makes the Earth warmer. So it sounded promising when you got to the first paragraph, but by the time you got to the second paragraph, you realize there's going to be some problems. So I want to ask you this question. I don't know if you can answer this question, but I always wonder this about these misinformers. Because when you look at what they're writing, it's very clever. It takes real thought to manipulate information and to cherry pick. You can't be dumb and cherry pick. You got to be pretty smart and cherry pick. So my question for you is, do you think, on the most part, because there's a whole bunch of these authors, but on the most part, that they know they're misinforming? Or do you think they really believe literally what they're writing?
I don't know what goes on in people's heads. People are weird. I do agree, though, that some of the things they do are so carefully chosen that it's impossible for me to believe it's just a random error. So if you look, people, I'm sure most of your viewers don't know the report as well as I do, but if you look at section 5.8, there's something about climate models reproducing temperatures in the Corn Belt region of the US. And if you look around the entire globe, that's the grid point. That's the models do the absolute worst. You could have picked almost any other grid point on the planet, and the models would have looked better than that. And you think, that's weird. How could they possibly have picked that single grid point where they do the absolute worst? And I think it's, I don't know. I don't know the answer to that, but it just seems very unlikely to me that it's random. It could be random. I don't know. But if so, those are the unluckiest scientists in the world.
Or we're all unlucky, unfortunately.
Yeah.
Okay, because that one, and by the way, I know there's many people fooled by this misinformation. And I guess if you're just watching Fox News and you just listen, you'll kind of believe that climate change isn't that bad. But those are not the people creating the report who have to do like what you said, like pick the worst grid point and just focus on this one issue and totally ignore the other issues that we all know about, and they must know about too. So anyway, all right, it kind of deserves a show all on its own, just like what's going on in the head. I have to bring in a psychologist or something instead of a climate scientist for that. So let's. By the way, I'm going to try to pull up. I don't know how this is going to look on here, but let's do a screen and a window and boom, and share this. And this is what the report looks like. And a critical review of impacts of greenhouse gas emissions in the U.S. climate. And it's the Climate Working Group, Department of Energy. And by the way, the authors are John Christie, Judith Curry, Steve Koonin, Ross McKirtrick, and Roy Spencer. Okay. And I actually, except for Ross, I know them all as well. So, and if we go on here, we can zoom in a little bit. Executive summary. I thought what we could do, because first of all, it's how many pages is your response? It's like 400 pages or something.
Yeah, it's like 450 pages.
So we're not going to have time to go through all of that. But I thought what might be useful is the DOE report itself contains an executive summary. And since it does, it's kind of already summarized like the whole thing, from their point of view. And it's making some statements that I think are questionable. And so perhaps rather than like getting into super detail, maybe we just take this report, the executive summary, and then you can tell me why what it's saying isn't as maybe accurate as it should be. Does that sound like a good way to go?
Sure.
So the first paragraph, I'll read the first paragraph because the first paragraph actually sounds pretty reasonable. The report reviews scientific certainties and uncertainties in how anthropogenic carbon dioxide and other greenhouse gas emissions have affected or will affect the nation's climate, extreme weather events, and selected metrics of societal well-being. Those emissions are increasing the concentration of CO2 in the atmosphere through a complex and variable carbon cycle, where some portion of the additional CO2 persists in the atmosphere for centuries. Hey, that all sounds pretty reasonable. So, okay, now let's move on. And I've highlighted on my own notes, I've highlighted some of this. But the second, let's get to the second one. Elevated concentrations of CO2 directly enhance plant growth, globally contributing to greening the planet and increasing agriculture productivity. I'm going to leave out the references. They just reference, the more detailed sections of the report. They also make the oceans less alkaline, lower the pH. That is possibly detrimental to coral reefs, although the recent rebound of the Great Barrier Reef suggests otherwise. Okay, CO2 is plant food. You put more CO2 in the atmosphere and it enhances plant growth. So what could be wrong with any of that?
Yeah, I mean, tell someone who's drowning that they need water to survive. You can't survive without water as they go down for the third time. There's no question that CO2 is required for plant growth. If you removed all the CO2 from the atmosphere, that would be very bad. But of course, that's not what anybody is talking about. And while in controlled situations, increasing CO2 can help plants, like in a greenhouse where the temperature's controlled, they're getting, optimal nutrients, optimal humidity, optimal water. Adding CO2 is good. But when you add CO2, you end up changing all of those other things. So you end up changing temperature and you end up changing the precipitation patterns. And if you talk to the experts, the people who really work on this, not me, but the people who wrote the section in our response, which was written by experts, they're very concerned about climate change, in particular the increasing temperature. Increasing temperature is going to be a big problem for these plants. As far as the earth greening, That is really misleading. The Earth is greening, no doubt about it, but a lot of that is in China and India, and that's the result of agricultural policies. In China, for example, they're really trying to reforest sections that were deforested earlier. In addition, they give big subsidies to farmers. So they're really trying to ramp up their agricultural productivity. And that's completely unrelated to CO2 fertilization. It's much more agricultural policies at mid latitudes. CO2 does seem to be helping at high latitudes. And that's a combination of CO2 increase, but also the temperature increase. If you go to, you go to northern Canada, it was too cold for plants to grow, or for for certain types of plants to grow. And now we've added so much carbon dioxide, the temperature's gone up, so now plants can grow there. But that doesn't help anybody. That doesn't help agricultural productivity. So yeah, this is really extremely misleading.
Also, by the way, I went to an early show we did on this program like couple of years ago. It was on vapor pressure deficit, something I didn't really know much about. But there's an article about how vapor pressure deficit has caused stop the greening, actually, or over. It's like becoming a bigger factor than the CO2 fertilization effect. Any quick comments on that?
Well, I mean, as the temperature goes up, sure, the atmosphere becomes thirstier, and you get evaporation goes faster, and so you end up drying out soils very quickly. In fact, as the temperature goes up, you end up with drought, not because of changes in rainfall, but just because of evaporation increases. We call that agricultural ecological drought, and that can occur even if your rainfall doesn't change. And so, yeah, there's a big problem with the warming temperatures really affecting agriculture in important ways. And of course, this report doesn't, I actually looked into some of the statistics of this, and I may not get all of the statistics right, but I believe there were about 20 references in this chapter. So they referenced 20 papers. Around 20. If you look at the equivalent chapter in the IPCC report, which is chapter 5 of Working Group 2, it has 3,000 references. So think about all of the references they're not talking about. All of the references that said that climate change would be bad for agriculture, that adding CO2 would be bad for agriculture. They just don't talk about them. They just ignore them. And
Right.
So
Cherry
it's
picking.
not in any way a legitimate scientific document. And I think this gets to something which I would like to talk about later. Just remind me about the process of this report. There's a saying that process is product. That what you get out at the end is only as good as the process that put it together. And this process was so opaque and so unscientific and unacademic that, of course, the report's going to be terrible because it never went through peer review or any kind of legitimate peer review. It's just so you end up with something which doesn't reflect what the science says. It reflects this particular view of 0.1% of the scientific community.
Okay. And by the way, in addition to you mentioned temperature, but in addition to CO2 fertilization positive, rainfall, heat, rainfall, fire, flood, disease, bark beetle. I mean, you can go on and on and on. I mean, there's a lot of negative impacts. And by the way, any statistics on, I don't know how you control for it, because you said there's all these policies and money being put in, but in sort of certain areas, whether agriculture is actually getting better on its own just based on CO2 in the climate versus dropping. I would think it's dropping, that we're getting hit by extremes, extreme weather.
I don't know those statistics. It's really not my area. I would recommend anybody interested to read our response to the report. Hopefully you can put that in the show notes.
Oh yeah, it already is. So
yeah.
The link to the DOE report is there. The link to Andrew's report is all there. So you want to get into the detail. I mean, it's a long report. We're obviously not going to be able to cover all of it. So yes,
but
please, everyone.
If you're interested in it, read that section that goes through in great detail what we think we understand about the effect of CO2 and climate change on agriculture.
Okay. And then we get to the next paragraph, third paragraph. Carbon dioxide also acts as a greenhouse gas, exerting a warming influence on climate and weather. On climate and weather. Climate change projections require scenarios of future emissions. There is evidence that scenarios widely used in the impacts literature have overstated observed and likely future emissions trends. Like to respond to that?
Sure. So the IPCC, there are four main scenarios that are and the scenarios are plausible ways the Earth could or the human society could evolve over the 21st century and beyond. And so they have four scenarios. Some of them are very low, very optimistic. The so-called SSP 126 is this extremely optimistic scenario. I think that's unrealistically optimistic. And then at the other end, there's the SSP 585, which is also probably unrealistically pessimistic. But if you're doing an exercise where you can't really predict how the world's going to evolve because we don't know what's going to happen politically, you want to come up with a very wide range of predictions. And so it's certainly the case that there are some scenarios that are that look too pessimistic, just like there are scenarios that look too optimistic, and the correct answer is probably somewhere in the middle. I don't think that, I think this is kind of a generic conspiracy theory argument. They're basically trying to argue that they're implicitly saying that, scientists have chosen this to be alarmist. They're trying to scare you into doing stuff. I don't think that's right.
Right.
I know these scientists. There are actually legitimate reasons still for you to use a very pessimistic scenario in your analysis. If, for example, you're trying to separate out the forced response, the response to CO2, from internal variability, which is kind of the natural variability of the atmosphere, like El Nino events. And it's really hard to separate those. And so what you want to do is you want to use a scenario that has a lot of forcing. So the forced response is really large, and then the unforced response is basically this, doesn't change. And so if you want to see the forced response, you want to use a really big scenario, a really big forcing, very pessimistic scenario. So this is just not a scientific argument. Basically, it's really a conspiracy theory.
Yeah. By the way, on that, the 8.5, which is a very high, assumes coal plants keep growing, whatever. However, my understanding is that while we're not following that emissions trajectory, we are following the forcing scenario based on 8.5. In other words, you translate emissions into forcings. By the way, for everyone, like a forcing is the energy that's changing the climate, I guess maybe it's a simple way to say it. Right. But when we actually look at the forcings, the Earth energy imbalance and that kind of thing, we really are at 8.5 levels. Is that true?
Well, I think at this point in time, 2025, all the forcings look basically the same. So there's not a big difference. It's really, you get past 2050, 2075, that you can really see them branching out. So the temperature, we don't see a difference in temperatures until 2050. The forcings don't really diverge. So it's kind of hard to say. It may be that it's slight differences and push us a little closer to that, but I'm not sure I would put much faith.
Right, well, maybe we'll get back after we cover the summary. Maybe we'll get back to some of those kinds of things. All right, so we let's see. So we got that. The next paragraph, by the way, it's only one page of the executive summary, so there's not too much on here to go through. The world's several dozen global climate models offer little guidance on how much the climate responds to elevated CO2, with the average surface warming under a doubling of the CO2 concentration ranging from 1.8 C to 5.7 C. Data-driven methods yield a lower and narrower range. Global climate models generally run hot in their description of the climate of the past few decades. Too much warming at the surface and too much amplification warming in the lower and mid-troposphere. The combination of overly sensitive models and implausible extreme scenarios for future emissions yields exaggerated projections of future warming.
Yeah, I mean, so there's some parts of this are right. I think it is correct to say that the doubling under, the warming under doubling CO2, I'm guessing that is right, 1.8 to 5.7 Celsius. But that doesn't mean that global climate models generally run hot. There are some models that run hot, but there are some models that look much more reasonable in the past few decades. And in fact, oftentimes people will screen out the hot models when they do their analysis. So, but it's definitely wrong to say that all models run hot. That is absolutely wrong. And I think that there's no reason to, and that the models have, people have spent a lot of time looking at the estimates of warming over the last few decades, and the models look really good. So I think it's, again, wrong to say that the models can't predict surface temperatures. Because you can look at a model that was predicted, that was run in 1990, and actually did a really good job of predicting how much warming we have now.
Even Jim Hanson's in 1981 did a good job.
Yeah, it's probably
the right emissions
limit.
Yeah,
you really want to go back further.
Exxon.
Yeah, I mean, Wally Broker in 1975 made a prediction that was quite good. Exxon. I mean, they made average projections. So I think this idea that exaggerated projections of future warming is just wrong. I mean, that's just
wrong. That is confuse everybody. Say, hey, look, if you do the worst of everything, you can get exaggerate. And then there's the case, I don't know, maybe we'll talk about it a little bit later, but the recent warming last few years, maybe because of ship emission changes or other things, we're actually warming more dramatically. There's been acceleration in warming recently. So, okay, there we go. The next paragraph. No, most extreme weather events in the US do not show long-term trends. Right there, we could stop. But claims of increased frequency of intensity of hurricanes, tornadoes, floods, and droughts are not supported by US historical data. Additionally, forest management practices are often overlooked in assessing changes in wildfire activity. Global sea level has risen approximately 8 inches since 1900, but there are significant regional variations driven primarily by local land subsidence. U.S. tide gauge measurements in aggregate show no obvious acceleration in sea level rise beyond the historical average rate.
Yeah, I mean, it's hard to, there's so much wrong here. It's hard to unpack anything. I mean, it's just, how many wrong things can you get into, what is it, like 3 or 4 sentences?
Yeah.
They've really compressed the stuff. Yeah, I mean, you could spend a whole day just talking about this. I mean, I think there's a couple things that are useful to point out. They say claims of increased frequency or intensity of hurricanes. All right, so nobody claims, or no scientific analysis claims that hurricanes are becoming more frequent.
Right.
And when they say not supported by US historical data, I think that's also kind of a weird thing to add. We do know that hurricanes are getting more intense. There definitely is evidence of more intense hurricanes, maybe not hitting the US, but certainly if you take into account the ones that don't hit the US, that stay out to sea, we know hurricanes are getting more intense. We don't know if that's due to CO2 though. The attribution of that is a little bit, is unclear. Tornadoes, we just don't have good data on them. They're rare events. There's a big bias in the fact that we can see people report tornadoes now more than in the past because everyone has a cell phone and there are more people out there. Floods are something where, again, it depends on how you define them. There's lots of different kinds of floods. There's coastal flooding from severe storm events. There's flooding from melting snowpack. There's flooding from rivers, and they each have different attributions. And I don't know, to be honest, I don't know about the US historical data on floods. Droughts, again, there are different kinds of droughts. There's hydrologic droughts due to rainfall. We don't see trends in those. There's agricultural and ecological droughts. We do see trends in those. And that's driven by warmer temperatures. Again,
Right.
you can generate a drought if you just turn up the temperature. Again, I don't know about not sort of a US historical data. Globally, we see trends in droughts. But, you know, one of the things that is true is that if you look at a small enough area, as the area gets smaller, you're more and more affected by sort of local variability. So think Dust Bowl. In fact, can you open my report?
Yeah, that's right.
Open my
Hold on.
report and go to section.
I think I have to wait, I think I have to hit this,
Right.
don't I? Because
you may not need to download it. You can probably just scroll in that window if you want to.
okay, let's see if this works. Okay. And where do you want to go?
Go see, figure out go to the table of contents, see what page it's on. But no, go down. You have to get, it's like 20 pages back. But the point is that the area, keep going. Look at the response to section 6.3. Keep going. Next page. Next page. Stop. Go to page 182.
Oh, is it
182?
okay,
yeah, that's
182. Zoom,
right.
zoom, zoom. Okay.
Yeah, so
a long report, guys.
It's a long report. So wow. One of the ways you cherry pick is you pick a very small region. Keep going. And if you pick a small enough region, then things other than climate change become, keep going. That's it. Go to the next page. All right, stop. That's the plot. That is the plot I want everyone to see. So this is the plot. This plot shows temperature, but it works for everything. And if you look at this plot, so this is temperatures above 105 degrees. And I just picked that because it was very clear with that threshold. So this is continental US. So we've cherry picked a region, the continental US, and we're looking at grid points that have temperatures above 105 degrees. And you'll notice there's no trend. If you put a trend line through this, the trend is basically zero, okay? And you might say, you know, what's going on in the 1930s? Why was it so hot there? It was because of the Dust Bowl. And the Dust Bowl is unrelated to carbon dioxide. It was due to some internal variability, some unforced variability, along with really terrible human agricultural practices that denuded much of the landscape, caused this drought temperature feedback where you dry out the soils, temperature goes up, you dry out the soils some more. And once the soils are dry, you don't get any evaporative cooling. The temperatures shoot up. And so the Dust Bowl was an extremely hot time. Now, if you look, we only recently passed the Dust Bowl. But the reason for the hot temperatures in the last few decades is completely different from the reason for the 1930s. The last few decades are due to carbon dioxide. Okay, that's due to global warming. And so by saying there's no trend, you're mixing up the physical causes. And this is actually one of the tricks they use, which is all they do is look at statistics. They never think about the physics, the underlying physics of the problem. In this case, we understand the Dust Bowl was not caused by carbon dioxide, whereas the recent temperatures were. And so we can say, even though there's no actual trend in this data, we can say CO2 is increasing the occurrence of very hot temperatures. Extreme temperatures are getting more extreme because of carbon dioxide. And we've now passed the Dust Bowl. But for a long time, that was the go-to argument for climate misinformers. Oh, it's hotter in the 30s.
Right. And by the way, it still is hotter, as it even shows here. It still is hotter today than it was in the Dust Bowl, even though that was very hot. And as I think you pointed out somewhere else, the contiguous United States, the lower 48 states, is I think 1.6% of the surface area of the globe.
Right.
And that's in Alaska and Hawaii, it's not much more, 1.8. I mean, it's still tiny.
Right. Yeah. And so by picking a small region, you're very subject to these kinds of non-climate variability or non-CO2 driven climate variability. So go a couple pages, go a couple pages. Well, I'll show you.
Farther?
Yeah, go
Okay.
further down. Keep going. I'll tell you when to stop. I'll show you another plot. Keep going, keep going, keep going, keep going. All right, stop, go back. Go back. Yeah, that's the plot right there. This is the whole northern hemisphere mid-latitudes. So if you look at this, you don't see the 1930s show up because the 1930s was a very local event in the US. When you look at the whole northern hemisphere mid-latitudes, all of a sudden the 1930s aren't dominant because that was very small. And so this is why you want to look at large areas, which they specifically don't do. They specifically don't do. And so if you look at a large area, you see that clearly there's a long-term trend towards more extreme temperatures. And this basically applies to everything, to much of what they did. When they say there's no trend, they're looking at small regions, or they're including non-CO2 related variability that you have to back out because they're basically ignoring physics. All they're doing is looking at statistics. And
Right.
Statistics are important, but physics is more important.
It's kind of funny because I've been debunking climate deniers for like 20 years now or more. And these are really old things that were debunked long ago. And yet to see them pop up again as if they're some serious argument is a little weird, but that's the world we live in right now.
These are the best arguments they have. And they're not going
And
to
they're
get rid of them
and
because if they got
they're
rid of them, they wouldn't have anything.
that's a good point. Okay. Anything on sea level rise you want to mention there?
I would say read the section. The chapter 7 in our response is really excellent.
And this is just wrong. I mean, sea level rise is accelerating. It's doubled in the last 30 years, is it, or something?
It is accelerating. It definitely looks like it's accelerating. I mean, they did know, will throw out, they did no analysis when they say shows no obvious acceleration. They just kind of eyeballed it and said, no obvious acceleration. But I mean, in science, you don't eyeball stuff. You can do tests. You can actually do statistical tests to see if it's accelerating. And if you do those, it shows it is accelerating.
But it's not even subtle. I mean, it's like I thought somewhere else we saw, and it's in your report, where it actually doubled. The rate of sea level rise has doubled since 1990 or something around then.
Yeah, I mean, so if you notice, they say U.S. tide gauge measurement. So they're using a very small subset. Again, they're cherry picking data. They're using a very small subset of the data. They're not using the satellite measurements, for example, which do show a really clear acceleration.
Okay. Wow. Yeah. Okay. Attribution of climate change or extreme weather events to human CO2 emissions is challenged by natural climate variability, data limitations, and inherent model deficiencies. Okay. Moreover, solar activity's contribution to the late 20th century warming might be underestimated. Okay.
Yeah.
Sorry.
Right. So, I mean, attribution of climate change to extreme weather events is really sort of a hot topic, no pun intended. And it is one that it's a very new scientific field in some ways. It's the very first paper on this was early 2000s, and really only in the last 10 years have people really started working on it. I do think, my personal opinion is that there are a lot of uncertainties in this. There are certain cases where we can be very sure that human CO2 emissions are making events worse. So things like heat waves. There's no question that we're making heat waves worse. Intense rain events, things like Hurricane Harvey. There's no question, we're heating the ocean. We see that the hotter ocean, you have more water vapor in the atmosphere. Then this water vapor converges into the storm, you get more rain. I mean, we understand that. And so there's some things where there are no challenges. It's pretty clear cut. Now, you could argue about the exact quantification. If you look at Hurricane Harvey, for example, some people say it's 20%. Some people say it's 40% of the rainfall was due to climate change. So there's uncertainty. But there's no question that we're making these events stronger. I think there are other events where it's really not nearly as clear. And so you can always cherry pick the events where you're not as sure and say this casts doubt on all of extreme event attribution. But, again, there are many cases where it's quite obvious that that humans are changing the weather, changing the extreme events in the weather.
And this is really just the merchants of doubt approach to things. They're not even trying to claim that it's like cigarettes cause cancer. They're not trying to claim that cigarettes don't cause cancer. They're just trying to claim that there's doubts, there's uncertainties about it, and that's the same thing they're trying to do here. By the way, originally were the same people who did cigarette disinformation were asked to do climate disinformation.
I'm well aware of that. Yeah.
Yeah. Okay. And by the way, one of my favorites is that Jim Hansen did a study long ago showing extremely hot summers where you take, the average summer temperature for every weather station in the world. And I think they looked at the northern hemisphere, so you could get one summer period be the right summer period. And they looked from 1951 to 1990. They had the average. It was like a bell curve of, sometimes the place was average, sometimes it was cooler, sometimes it was warmer. And the amount of time it would be 3 sigma warmer was 0.1%, which is about right for a bell curve. And then you look at it the last decade, and that 0.1% was 22% because the whole curve shifted over. And that meant the extremely hot summers increased by 20,000% since about 50 years ago. And that's not just a mathematical thing, it was real. And it also says, by the way, statistically, that if you ever have an extremely hot summer, there's a 99.5% chance that it was caused by climate change, not by natural variation, because it's 200 times more often. It's happening 200 times more often. So anyway, there's that. And again, especially when you get into extremes, you can really show attribution, I think, in many of these cases. Right. All right. We're near the getting to the end of the executive summary. Attribution of climate. Oh no, we did that. What about the solar activities contribution? I think that's
just wrong. So we actually have we have in the report we have a good response to that, and to be honest, I can't remember exactly what it was. My memory, if memory serves, they essentially were leaning on a particular reconstruction of solar variability. So just to make sure people understand, only for about the last 40 years can we actually measure the output of the sun, because you have to do that from orbit. You can't do that from the ground because the atmosphere absorbs and scatters sunlight. So you have to, you can make direct measurements that go back to the 70s. If you want to go back further than that, you've got to basically do what we call sort of proxy reconstructions. You have to find something that we can measure today that tells you what the climate or what the solar output was, 200 or 300 years ago. And there are various ways to do that by looking at I'm not even going to go into it because I'm sure I'd get it wrong. But
there's sunspots. I mean,
you can measure sunspots, but you can also do these isotopic measurements of nitrogen and boron and other things that get incorporated into rocks and trees and stuff. I probably butchered that, but you can do it. And different people have come up with different estimates of what the sun has done. No changes. Everybody agrees in the last 40 years because we have direct measurements. But you go back further, and you can get very different estimates. And so they're leaning on one particular reconstruction that shows the sun's gotten a lot brighter over the last few hundred years. But that disagrees with several other analyses. I think people don't believe that reconstruction anymore.
But so also over just the last 40 years when we do have direct measurements.
Absolutely. So that's right.
The temperatures have been going up, and the solar cycle has been going up and down. And when it's down, temperatures are still up. So
yeah, most of the warming is the last half century, and we have direct measurements in that period. So it's a very weak argument.
Okay. Well, it's actually more than weak. Probably right. Okay. Both models and experience suggest that CO2-induced warming might be less damaging economically than commonly believed, and excessively aggressive mitigation policies could prove more detrimental than beneficial. Social cost of carbon estimates, which attempt to quantify the economic damage of CO2 emissions, are highly sensitive to their underlying assumptions and so provide limited independent information.
Yeah, so go back to my report. There's one plot I want to show you.
Okay.
It's the last
Go
tab.
here. Yep. Click on here. Yep.
Go down like 100 pages. It'll be to the chapter 11.
Okay. What do you know roughly what page number? No.
Probably about 380.
Okay. We're zooming through here. Let's see. Where are we? 314. Wow. Okay.
There are a lot of comments. Keep going.
Wow.
Keep going.
360.
Stop. Go to like 320.
Oh, 320. Okay.
Yeah,
Go back up.
I got that wrong. This is the section right here. Keep going. Stop. Go to the next section. Sorry. Yeah. So I would say people that want to understand this should definitely look at the chapter 11 response in our report, which we're going to right here. And it's really very well done. I'm not an economist, so I don't really want, keep going. Sorry. It might be too hard to find it, but go back to the other. I don't want people to see here while we're flipping around, or maybe you could find chapter 11, the chapter 11 response. Maybe it's 30 or 40 pages down. And I'll just say, so the main problem with these economic arguments is that, a lot of people have done a lot of work over many, many decades. And I think up until about 2010, it was, next sections, go down, keep scrolling down. Up until about 2010, there really was this consensus. No, keep going. We want chapter 11. There was this consensus that climate change, keep going down. I'll tell you when to stop. There was this consensus that, climate change wouldn't be, this is it. Keep going. Stop. That's the figure. That's the figure right there I want to show. And I'll talk about that in a second. Up until about 10 years ago, there was this, or 15 years ago, there's a consensus that climate change wasn't going to be this big economic problem. At least a lot of economists would tell you that. There were a few economists like Martin Weitzman who said, you have to be really concerned about the worst case scenario and stuff like that. But there was this idea that it wouldn't be that big a deal. And then in the last 10 years, I think there's been a lot of changes in economics. And now economists understand that there's enormous uncertainty in these estimates, and that we really don't understand how climate change is going to affect economics, because we don't have any theory like Newton's laws. We can predict future climate, even though it's never happened, because we understand that whatever climate occurs has to be constrained by the laws of physics. So conservation of mass, conservation of momentum, conservation of energy, things like that. That constrains what the climate's going to be. So we can predict climate into the future. Economics doesn't have that. They don't have these fundamental laws that the economy has to obey. And so they really can't predict outside of what we've experienced. Because it's all statistical modeling. So anything that's sort of in the future, you have to extrapolate from sort of present day observations. And how do you do that? Is it a straight line? Is it a parabola? Is it exponential? You don't know. And so I think that the idea that we can confidently say the impacts will be much less, you can only say that if you cherry pick. And that's why I wanted to look at this picture. This is a probability distribution that shows how many estimates of each value of the social cost of carbon there have been. And you can see there are a lot of estimates at $25, $50, $75, $100, but there's this really long tail. There are some estimates that it's $800 a ton. And again, what that means is if you emit a ton of carbon dioxide, it causes $800 of damage, appropriately discounted back to present day. Now, the DOE report used the red bars. That's what they analyzed. And so when they say evidence suggests that the impact is very low, it's because they're throwing out 99% of the evidence. you can always say that if you're willing to throw out all of the evidence that doesn't agree with you, you can always say the evidence agrees with me because I've thrown out all the evidence that doesn't agree with you. And this to me is one of the most powerful plots that really shows sort of the intellectual gymnastics that these people had to go through to make the case.
Now this has dollars per ton C, which would be ton of carbon, not CO2, which
That's
is
right.
higher. By the way, I had David Archer on one of my first climate chat shows, and he did a calculation of what was the social cost of carbon, which he called the ultimate cost of carbon, if you don't discount it. And the number was $100,000 per ton of C, or about $27,000 per ton of CO2, something like that. But so we're just ignoring future generations and all of these things. And this gets back to William Nordhaus winning the Nobel Prize for saying that 3.5 degrees of warming was optimal, even though it would like totally destroy civilization. But
Yeah,
in
I
his
don't.
mind, he had some trade-offs that he thought were reasonable. So
Yeah, I don't. I think people dunk on Nordhaus a lot for that, and again, I think that up until about 2010, a lot of economists actually believe that. But I think in the
oh yeah, they
last,
can believe it,
but I think
sure.
a lot in the last 15 years, I think views, or at least since the IPCC fifth assessment report, which is 2013, the views of economists have largely changed. If you look at Nordhaus's more recent work and his Nobel Prize acceptance speech, I think again, I don't know him, I don't know what he would say, but sort of my interpretation of what he would probably say to you for that is that that's what the model gives, but we understand the model's not good enough to actually bet the future of civilization on it. And I think
And the
that's the way.
University of Exeter just issued a report from their faculty of actuaries, where there are the kinds of people that really do look at this stuff, and they said it's just wrong fundamentally the way you're looking at risk. You just fundamentally, and that's what, of course, this whole report here. It's saying, I mean, it's just like cigarettes. Well, we're not sure. So it's the implication, since we're not sure, let's keep doing what we're doing. No, no, no,
Yeah.
that's not the way it works. If you're not sure how many bullets are in the chamber of the gun, you don't just say, well, I don't know how many bullets there are, so I'll play Russian roulette with it. No, no, you don't. You do exactly the opposite. Uncertainty is not your friend. When you're talking about existential threats, you have to assume the worst. So if you're not sure, you have to say, "Oh my God, I'm not even sure. I better assume it's going to be, we're going to hit 5 degrees, later this century unless I act." And they're doing exactly the opposite. And of course, they're using words like uncertainty, and they're translating them from the scientific meaning into sort of the social meaning, and people don't get it. It's like using theory to mean that something we don't know about it, where theory and science means you really know about it, right? And so I think that's a lot of what this disinformation is all about. Oh, we don't know, we're not sure, so let's just keep doing what we're doing,
Right.
which is
That's right.
exactly wrong. But that's what's, and you would lose like every war if you ever like had military strategy that was based on that.
Yeah, I mean, it's especially wrong because doing something about it is not just free; it actually saves us money. I
Right.
mean, we don't know how to get to net zero yet. I think the technology to do that has not yet been invented, but we know how to get to 90% decarbonized uh, and pay nothing for that. And if we go to
Mm.
80%, we'll save money. And so I think that the argument really falls on its head once the solution of solar and wind to decarbonize became cheaper than fossil fuels.
Right. So they just lie all about that too, of course, like Trump and
That's
everybody. But
yes.
yeah. So I think we have one paragraph left to go. Let's see. Both U.S. policy actions are expected to have undetectably small direct impacts on the global climate, and any effects will only emerge after long delays. That's a really interesting statement to end with.
Yeah, I mean that's wrong. Yeah, I mean those are wrong in two ways. First of all, the effect. One of the things that we've again understood in the last 10 years is that the time to maximum heating of carbon dioxide emits about 10 years. So if you dump a ton of carbon dioxide in the atmosphere, it will reach its maximum heating in 10 years. And after that, the heating starts to fall off. It takes a very long time for it to get back to zero, thousands of years or tens of thousands of years. But still, the maximum is 10 years. So if you don't emit carbon today, you have a detectable, it will have an impact. Depends on how much, whether it's detectable or not. But 1 ton is probably not detectable. But if you don't emit carbon today, it will have an effect in 10 years. And that's certainly within the scope that most people care about. As far as US policy actions expecting to have undetectably small impacts, the argument they were making there was extremely bad. It was, what's the trend? Could you detect it given the uncertainty in the observed trend, which is not how you do this calculation at all, because the impact is you always have to model something like this. You can never measure directly the impact of future or even past. I can't tell you the impact of past policies because you always directly from observations, because you always need to do a calculation of the counterfactual world where the policy didn't take place or the policy does take place. So you have to model it. You can do the calculation. So the idea it's undetectably small is just wrong also.
Yeah, by the way, I didn't think it would take this long to go through that one page summary. Do you have a little more time? Because we have some questions from our co-mods, and I have some, if you have time, some questions, and
Sure,
a
we can
few
keep
from
going.
YouTube. But you wanted to mention, and you kind of did, but about the process of the report. Do you want to
Sure.
say
I mean,
anything else on that?
let's just go over this. So the Secretary of Energy handpicked 5 people who said things that he liked. All right. So that violates rule number 1 of how do you do a scientific assessment. You don't go out and handpick people who tell you what you want to hear. That you do not get good scientific advice that way. Number 2, the report was basically written in a very short length of time, a few months, and it was not peer reviewed. Now they claim it went through an internal DOE peer review, but some of the errors in it were so egregious that it's quite clear it never went through any kind of legitimate peer review. And that violates rule number 2. You look at the credible assessments, IPCC, National Climate Assessment, they go through several rounds of peer review. And, that it's not final until it's gone through public review, scientific review, US government review. I mean, it's many layers of peer review. And that's how you get a reliable report. And they didn't do that. And so I think that it's no surprise that this is a travesty, a mockery of science, given the process that produced it.
Okay. And let's see. Well, I have so many questions for you, but let's. Leon, are you there? Because you had some questions. Okay. I mean, I'll get to mine later if we have time. I want to give you and Stacy, Eli, and the others up. Let's put Andrew over here. Okay. Welcome, Leon.
Yeah. Hi, thank you. Hi, Andrew. I have 2 questions for you. One in relation to the report, and you didn't really address this yet, and I think it's like the question, like, let me just ask it. So why did the Trump administration even bother to solicit this report through the Department of Energy? Because they use these ridiculous the green scam arguments last administration, and they got out of the Paris Agreement without any fake scientific assessment. So why do they even bother to write this report and now even not respond to all the criticism and just, as I understood it, stop this process and not proceed further?
Right. So that's an excellent question. And it goes back to the overarching political arguments here. So there's something called in the US called the endangerment finding. That's part of the Clean Air Act. And basically in 2009, the EPA declared that CO2 was a dangerous pollutant and it therefore has to be regulated by law. And a lot of US climate policy rests on this endangerment finding. And so one of the great goals of the Trump administration has been to try to figure out how to undo the endangerment finding. And so this report out of the DOE is basically, if you ask the question, why was it written in the first place? It was written to support the rollback of the endangerment finding, which the EPA is trying to do. And if you look at the EPA document where they propose rolling back the endangerment finding, it heavily cites this DOE report. And so I think you have to sort of understand the overarching strategy. Now, the problem for them is going to be that my understanding of the law is they have to respond to every comment that was submitted on this if they want to roll back the endangerment finding. And I think it's going to be impossible for them to respond in any way that can survive legal challenges. And I think this might end up, they might have made a profound mistake going after the science, because I think they could have made arguments about the endangerment finding without making these really tendentious scientific arguments, just making legal arguments about how the law is written and how it's interpreted and things like that, which obviously science doesn't have anything to say about it. But because they went the science route, that they're going to have to answer all these questions. And I think that this may actually end up sinking their efforts to repeal the endangerment finding. We'll see what survives in court. But, I think and then you might say, well, why'd they do that then? And I think there are some true believers in this Trump administration, people like Chris Wright. He truly believes that his view of science, of climate science, which is reflected in this report written by these 5 people who represent the 0.1% or 0.01% or 0.001%. He really believes it's true. And I think he's just profoundly misinformed on the issue, as he is on renewable energy. I mean, it's, people, when he first came in, people talked about how smart he was. I'm still waiting to see evidence of that. He's just really profoundly misinformed on climate change. I think they may have made a really terrible mistake trying to do this.
Okay. And Leon, you had a second question?
Yeah, the other question is relates to the greenhouse gas forcing, and I wanted to hear your thoughts on what the current greenhouse gas forcing, how it relates to a doubling of the CO2 forcing. Because if you see the recent update by Forster et al. On the greenhouse gas forcing in 2024, if you add all these greenhouse gases up, including methane and tropospheric ozone, and it already adds up to over 4 watts per square meter. So would you agree with the statement that we've already reached a greenhouse gas forcing equal to a doubling of CO2?
You're not including aerosols, are you?
No, greenhouse gas forcing. No, I don't.
Gas forcing.
Excluding aerosols and land use change and black carbon and sulfur, of course.
I wouldn't actually, to be honest. I haven't looked at that paper. I really don't. As I told Dan earlier, I've really kind of switched my research away from doing sort of the global physics, climate physics, and now I'm doing sort of more impact stuff. So I don't read the same papers I would have in the past, and so I haven't looked at that. But if you look at the last IPCC report, I think the total greenhouse gas forcing was 3.3 watts as of 2019. So I wouldn't be surprised if that plus a few warming aerosols was giving you close to 4 or 4. I think, though, if you add aerosols in, we're still below doubled CO2.
Yeah, for sure.
So, ultimately, we understand there are these things these numbers we don't necessarily know exactly, but we have a really good feeling for what's going on. I mean, every year we're increasing the forcing. And, it's good. And every year we're getting more warming. And as it warms, it's going to be worse and worse for humanity.
Thanks.
Well, while we're on this, I would maybe ask you just a follow-up. Jim Hansen, who've had on here not too long ago, he says he has 3 different lines of evidence to show that ECS, the equilibrium climate sensitivity, is really 4.5, not 3 degrees as used by the IPCC. So I don't know if you had a chance to read his paper. Actually, Leon was a co-author on the original global warming of the pipeline paper. But did you have any thoughts or comments on ECS being significant 50% higher than what the IPCC was assuming?
Well, I mean, the IPCC range, their likely range is 2.5 to 4. So it's not, it's, 10% or 12% higher than the upper end of the range. Given how uncertain it is, I think you can't rule that out. But there is a lot of there's a lot of evidence, a lot of pieces of data you can look at to say what is climate sensitivity. And some of them are kind of pointing here and some are kind of pointing there. And so I am hesitant to confidently conclude it's 4.5. I think it could be. I'm not going to say that's wrong, but just if you add up sort of the underlying feedbacks, which is what I spent a lot of my career looking at, and you sort of say, okay, we have these feedbacks, let's add them up. You get 3.5. That's to me still the most likely estimate. But Jim, I give Jim Hance a lot of credit. He has gone out on a limb and had a lot of people say that doesn't sound right, or I'm not sure. He's always been right. So I think you doubt Jim at your hazard. So I'm never going to say he's definitely wrong, but
I think a lot of it has to do with the recent studies on cloud feedbacks. That cloud feedback, there's less clouds when it gets warmer. George Salutis' work and NASA, and if that's a major factor if that's actually happening, which it does appear to be happening because it's like satellite data. But so anyway, that's a whole other. We spent many hours on that here, but I just wanted to know if you had an opinion. So Leon, should we go to Stacy and
yeah. So can I ask one more question about
okay.
So a recent paper you co-authored was I think it was stated like the Earth's energy imbalance has more than doubled. Maybe you want to talk about this in like a few sentences, cover this on a few sentences that this
well, I
necessary
mean,
data.
this is the AGU Advances paper by Torsten Murtzen. Yeah, I mean the point. Yeah, I mean, look, if you look at the data, it's clear. There's clearly something going on. Whether that's a forced response or an unforced response is really the question. So I had a graduate student, probably the last paper on this I wrote, 2020, 2021. We looked at the series record and looked at the cloud feedback if we took different windows in that period, and you get really widely varying values of what the cloud feedback you would infer from it is. So I am sort of hesitant to look at sort of short-term events and read too much into them. Is this sort of, we're getting to the point where this is all sort of cutting edge science. And if you go to a scientific meeting on something which is a hot topic, you'll talk to 10 people and 10 people have different opinions. Like, I think this is right. I think this is right. I don't believe that guy. I don't believe, and that guy says, I don't believe this guy over here. So, everybody kind of has their own opinion. It's the things that we all agree on are, I think, the things that people should focus on. What are the things we all agree on? Earth's warming, humans are to blame. We're on track for, 3 degrees of warming. And if it's 4 degrees of warming, that doesn't actually change anything. 3 degrees is bad enough. It doesn't have to be 4 degrees. We can transition our energy system largely for no cost right now. We should be doing that.
Yeah, I think so why we talk about this acceleration quite a bit is because it does impact, of course, how we should adapt to the near-term changes if the Earth is warming twice as fast as has been over the past decades.
Yeah, I mean, I guess, yeah. I mean, look, I don't want to. We're on the verge of having this head off into its own discussion. Yeah, I mean, look, I certainly think that we do need to be adapting. We're not adapting nearly fast enough, even for a best case scenario. We're not adapting. In fact, in many cases, we're anti-adapting. We're doing things that explicitly make us less resilient to climate change. So, I think we definitely need to be thinking about those issues.
Thanks.
Very good. Thanks, Leon. And we're going to go from Leon to Stacy, welcome. Oh, you have both cats there.
Yes.
Andrew, we
Puppy and
realized having
puppy.
cats on the video would help increase, viewership because
We're
it's just
trying to get the
YouTube.
algorithm going so that more people can hear about this. Thank you for your work on responding. It just, I am in shock daily on however many fronts there are, and especially climate, with the current administration. So I'm glad that there are sane and educated people like you, and that you rallied so many others to fight back. um, the one thing that I had that I've been saying this a lot, and I kind of wanted to check it. P. Schmidt sort of said the same thing, that deniers deny, most of them don't deny that the planet is warming. They just question to what extent such as is natural. And my response has always been, it doesn't matter. If we had nothing to do with it, but somehow the earth were warming and there was something we could do about drastically de-warming it, wouldn't we want to do that, like, to save us? Is that, do you think that's a valid argument, or no, we don't want
Well, I
to
think
mess with
that,
what's going on?
yeah, I mean, it's an interesting question. I think that when you look at your potential responses to climate change, you really do have to know what it is that's causing it. If this were all natural variability, so just the climate's just getting warmer on its own, do some change in ocean circulation, or the sun's getting brighter, or the orbit of Jupiter, insert whatever your favorite thing is. If it were that, then I think our responses to climate change would be different than if it's carbon dioxide. Because if it's carbon dioxide, then you really need to stop emitting carbon dioxide. And you need to do that by converting your energy system to one that doesn't run on fossil fuels. If it's natural, then you really need to think about adaptation. Maybe you need to think about geoengineering more. So I think it doesn't matter in the sense that you need to respond, but what your responses are going to be probably does matter on the cause.
Yes, of course. Yes, thank you. And then some other questions. Can I get into those now, Dan?
Yeah. And also mute your mic after you read them because I think there's a little feedback.
Oh, okay. Sorry. At 11:04, Nadia asked, is the destruction of the entire scientific establishment in the US opening up a vacuum into which pseudoscience, like the Energy Department's report, can slide? Will there be any scientists left to object in 35 years?
Well, that's a good question. I mean, I don't know the answer to that. Certainly, in a world without science, something will fill the void. And because we live in a world where you can monetize misinformation, I think people will be, on Twitter and making podcasts and getting rich, in much the same way they did it with COVID cures. And so, yeah, I mean, I think that very well may be the future in a world with fewer scientists.
That is just tragic. The other question, I don't know if you can still get to it. No, I don't think you can, Dan. 1037, P. Schmidt asked, can you explain how causality has been established between warming sea surface temperatures and decreasing cloud area? How do we know warming SSTs result in low cloud area and not the other way around?
So yeah, I mean, that's a good question. So one way you can do it is you can look at the energy balance. So we know how much energy it takes to change the temperature of the ocean, and water has a really high heat capacity. So if you have a layer of water 100 meters deep, it takes a lot of energy to warm or cool that. We know how much energy clouds can shade. Clouds shade the ocean. So, and we know how much energy that is. And so we can try to close the energy budget and say clouds are causing this, and it doesn't work. It's just not enough energy there. So it's really got to be that it's got to be that the surface temperatures are changing the clouds.
Okay.
Okay.
Well, thanks.
And
Well, yeah, go
oh,
ahead.
sorry. I mean, there were a couple other just sort of
Let's do
fact.
one more because I have one I want to ask as we
Okay.
finish up here.
Someone said, Charles said, none of the 20 references, speaking about the energy report, has any data that includes the last 5 years. Is that true?
I can't comment. I don't know if that's true
Okay.
or not. That certainly could be true. You know,
I'd buy it.
as a general rule, their referencing was very poor on what they reference, and you know, it was not necessarily the latest stuff or the most important stuff. It was really stuff that supported their weird views. It wasn't, you know, was not what you consider to be sort of a citation list from professional qualified scientists.
Okay.
Okay.
Well, thanks, Stacy.
Sure.
All right. Let's see. So, well, let's first of all hide that message and let's make you the big one there. Okay. Hi. uh, so as we first of all, thank you. First of all, I want to repeat what Stacy said. Thank you for all this hard work that went into it that you and the others did to help protect us by getting real science out there. I want to just hit a few other. We did cover a few other kind of hot topics in climate. One, by the way, that we've talked on this program recently is how soon we're going to be hitting 2C and 3C, kind of on the path we're on, which people are saying like in the 2030s, if you look at like all the different models and everything like that, it will be hitting 2 degrees. Do you agree with that assessment?
I think we'll hit 1.5. So it depends on how you define it. If your definition is we'll have 1 year that 2 degrees, I think might we hit it in the 2030s? I'm not sure. Certainly, if you look at sort of like the Paris Agreement definitions of 1.5 and 2, which is a 20-year average, we'll probably hit 1.5 C in the 2030s and probably 2C 2050s, 2060s, maybe.
But that's 20-year average, which doesn't really apply. I would say we've spoken on this program. We're at 1.5 now because the trend, in other words, it's unlikely that the average temperature going forward will ever be below 1.5. And that's sort of, that gives you what's happening now versus just looking back 20 years. Because 20 years gets averaged over lower temperatures.
I mean, the problem with looking at single years or 2 years is that you're strongly influenced by unforced variability. So the last 2023, 2024 were big El Nino years. We know the Earth's a few tenths of a degree warmer during an El Nino year. If you look at the last 10 years, we're at about 1.3 Celsius. So, you know, that's sort of, if you ask me how much warming, that's the number I would give you, the 10-year average, because a 1 or 2 year average is not as meaningful as a 10-year average.
But we're in like a La Nina now, and we're not below 1.5, I think, or maybe we are just a tiny bit, right?
We're probably, yeah, I mean, we're not much below 1.5.
So if you average out El Nino and La Nina, you're at, if you get rid of the natural variations by averaging them out, that sort of tells you where you're at. Oh, all right, well, let's skip on that one and get to maybe, we'll just end on just see if you have an opinion on this. We didn't talk about this before, but we talk a lot about this program, but hey, we're going up to 3 catastrophic AMOC tipping points. I mean, on and on. One thing we could do that would have an impact quickly is solar radiation management. I saw your co-author, Bob Kopp, was just recently tweeting about this subject. Do you have any thoughts on SRM and whether you think it's something we should research even more or something that concerns you greatly or anything like that?
Well, I think we should research it. You know, my views of SRM and, you know, stratospheric aerosol injection or solar radiation management in general is that it's kind of like the airbags in your car. You know, no one wants to use them, but if you're in a bad enough situation there, you know, your life could depend on them. And I think you can imagine a scenario where it's 2040 and climate change is out of control. Jim Hansen's right. The climate sensitivity is very high. All the people that said RCP 85 was impossible were wrong. You know, you can imagine a scenario like that. And in that scenario, maybe you do want to deploy solar radiation management. It's your last chance to avoid really bad impacts, the kinds like in, Ministry for the Future or something like that, a heat wave that kills millions of people. So, maybe you do. And I think if that's a possibility, then you should be studying it. So I do think that you want to be researching it. Now, that said, I agree with what Bob Kopp and others have talked about the governance issues. I think the governance issues of SRM are really daunting. But I don't think that should stop us from doing research.
Yeah, we've done whole programs on the governance issue here as well, and so that's good. Yeah. By the way, I love your airbag, because I've been using the chemotherapy analogy, but I like the airbag one. That's really good. So Andrew, thank you so much again for the work you're doing. I mean, this is not like paid work you get to do. I mean, you get to spend your summer, instead of having fun, just writing lots and lots of pages of stuff and coordinating 85 authors. But it came together. You covered the whole subject, did a great job. And as you were just pointing out, it actually may protect us by preventing the endangerment finding from being overturned, because they decided to go down the science path where they really didn't know what they were talking about. I sometimes like to figure out this idea: do they really know? Do they believe what they're saying? And so Chris Wright probably does, by the way, because he's just listening to the others, right? He's listening to what he wants to listen to. But does Judith Curry, does Roy Spencer really know, or do they know they're manipulating? I guess I don't know. Or I'm not sure it matters, but it's something that I wonder about.
I have to say, if they're going at, if this DOE report ends up sinking their efforts to repeal the endangered finding, that would be just like perfection. That would be just so hilarious if that's really what caused them to do it. I think there's a legitimate chance it could. Again, you never know what'll happen in court, but it could, that would be absolutely hilarious.
Yeah, and in courts they actually care about facts.
Exactly. In court cases
and evidence. So that's
courts
like
are venues where I was involved in a court case with Roy Spencer and Judy Curry were experts on the other side, working for Peabody Coal. And they lost badly because of the requirements of providing evidence. That's traceable evidence where you have to respond to what the other person says. They couldn't do it. Yeah.
And the cigarette companies also similarly lost eventually in court. It took a long time, but yeah. Wow. That's a great point to end on. That's great. So anyway, thanks so much. Thank you for being on the program and for all the work you're doing. Just one last question. Now that you finish this for a while, what current research are you working on?
Well, so I'm doing stuff that, looking at the impacts of climate change on human society. So I have a student who's looking at climate change and how it affects energy systems like our grid. I have another student who's looking at mortality, climate change and mortality. And I have a student who's looking at climate change in real estate in Houston after Hurricane Harvey.
Oh, very good. Okay, that's great. I appreciate that. And for all listeners out there, thank you for joining us, and make sure you like and subscribe, leave a comment below, share this with your friends, because this is really important information, and not enough people are listening to what's really going on in climate. So please help us spread the word, and your liking and subscribing does help us do that. Andrew, thank you again. Thank you for being on Climate Chat. And to everyone else, we will see you next time. And Andrew, you can stay on for a second after the title slide.
Sure. Thank you.
Bye-bye.